Good evening, everyone. I hope all of you are doing really great. Welcome to the first lecture of engineering mechanics. Now, this is the beginning of a very exciting journey for all of us. So, I hope all of you are ready for this. Good evening, good evening, good evening, good evening. A very warm welcome to all of you, as this is the first lecture of engineering mechanics. This is just the beginning. We are going to have a lot more fun. We are going to complete this entire engineering mechanics syllabus, and in this lecture I am going to tell you everything you need to know about this course. If you have any questions regarding this course, whether this course is useful for this particular exam or that particular exam, what is engineering mechanics, what will be the syllabus, what are the chapters that you are going to cover, which books I need to refer, everything I am going to cover in this particular lecture. So a very warm welcome once again. Now, before I start this, let me introduce myself. Some of you might know me, but most of you might be watching me for the first time. So let me introduce myself. My name is Aprup Rao. I am All India rank 320 in Gate Mechanical. M.Tech from IIT Kharagpur. My specialization was design because I was fascinated with the subjects of design. So when I got into IIT, I chose this specialization. Then in my final year of M.Tech, I was placed in Mahindra and Mahindra. I was posted at Mahindra Research Valley, which is the research and development center for Mahindra cars as well as Mahindra tractors. I was part of some really cool projects at that time. KUV, TUV, all these vehicles were being designed. But after 2 years, I decided that this is not what I want to do for the rest of my life. So I left my job and I started teaching. So I have been teaching for more than 8 years now. And my favorite subjects to teach are engineering mechanics, strength of materials, machine design, theory of machines, vibrations, etc. All the subjects of design, all the subjects related to design which are in the syllabus of GATE or engineering services. Okay. Now, in this lecture, what we are going to cover? So we are going to first have the introduction of mechanics. What is mechanics? This is something that I really want you to know, because unless you know about the subject, you will never have that interest. You will never understand it completely. Okay. So first you need to understand what exactly do we mean by mechanics. What is engineering mechanics? And then we are going to talk about the syllabus. We are also going to talk about which books you need to follow. I'm also going to explain whether this course will be useful for you or not. What all exams you can, if you are preparing for those exams, whether you will be able to get the benefit from these lectures or not. Okay, so we are going to cover all of that. So let's start this journey with understanding about mechanics. What do we mean by mechanics? What is this subject? What we are going to learn in this subject? Okay. Mechanics is basically the branch of physics that considers the action of forces on bodies that are at rest or in motion. Basically, in engineering mechanics, or in mechanics, if we use this term broadly, basically mechanics means the study of forces and its effects on bodies, whether that body is in the state of rest, or whether the body is moving. Let me give you an example. For example, let's say you are a designer and you want to design a bridge. It may be a road bridge or a railway bridge. Okay. Now, in order to design that bridge, you will design each and every members of that bridge, right? Now, the bridge will be in the state of rest. The first information that you would require is when the people will walk on that bridge or when the vehicles will move on that bridge, what forces those members will be subjected to. What will be the forces of the weight of those vehicles, weight of the people that will come on to the members of that bridge. Now, this is the case when the members of the bridge are in the state of rest. But if you are designing members of machines, let's say you want to design a car, so the components which are connected to the engine, they are moving. Now if you want to design those members, you will study what are the forces acting on those members. Now in this case the members are in motion. So mechanics is basically study of forces and its effects on bodies. Those bodies can be at rest or those bodies can be in motion. Now engineering mechanics is the branch of engineering that applies the principles of mechanics to mechanical design. See, when I say mechanics, it is a broad term, okay? A lot of things come under mechanics. But when we say engineering mechanics, then it is the application of mechanics to engineering problems, okay? So being an engineer, we only need to focus on the application of mechanics in engineering problems. Now, mechanics can be divided into two parts based on the type of material that you want to study. If you want to design a member, that member can be made of a solid material or that member can be fluid. For example, if we talk about hydraulics, hydraulic brakes, then it comes under this. So there are two branches of mechanics. One is mechanics of solids, where we study about the solid bodies, and one is mechanics of fluids, where we study about the fluids. Now mechanics of solids is further divided into two parts: mechanics of rigid bodies and mechanics of deformable bodies. Now what is the difference between these two? Mechanics of rigid bodies and mechanics of deformable bodies. Rigid and deformable both are solid bodies, okay? Now no body, no solid material is 100% rigid. Then why do we have this branch, mechanics of rigid bodies? In this particular branch, in order to understand certain principles, in order to apply certain principles, we assume that the material is rigid. Actually, we are studying about the same material which we study here. Here also we are going to consider steel, aluminum, copper, etc. Here also we are going to consider the same materials. But here when we study about those bodies, we assume the material to be rigid. Now why do we do that? So let me give you an example. Let me give you a small example, okay? Let's say we are studying about structures. What are structures? Structure means truss, frames, etc. You might have seen this railway bridges, right? Those are structures. So let's say we are studying about structures. Let's say this is a structure, okay, which is subjected to forces like this, and we want to calculate the force developed in each of these members. There are different members, okay, all these are different members, and we want to calculate the forces developed in each member. I am applying force here, I am applying force here, I am applying force here. Now due to these forces, there will be some force developed in this member, some force will go to this member, some force will go to this member, some force will go to this member, this member. In order to calculate those forces, in order to calculate the forces that go into these members, what we need to do? We need to consider this diagram. Now there are distances and angles that we already know. Let's say this is 2 meter, this is 2 meter, this is something, this is some angle, this is some angle. So all these distances and angles are given, okay? We are going to use these distances and angles, okay? Now after the application of these forces, will these distances and angles remain same? No. there will be some deformation, right? These bodies are going to deform and these angles, these distances, they are going to change, right? If I consider that change, will I be able to find these forces in the members? It is going to become very difficult. So what we assume, if I want to calculate forces in these members, then I will assume that these bodies are solid, rigid bodies. They are not going to deform. Let me give you another example. Okay, this time I am going to give you an example of a beam. Let's say we have a beam like this. This is known as a cantilever beam. Okay, some of you might know about this. This is known as a cantilever beam. Let's say it is subjected to a force like this. Let's say this force is 100 Newton. This is point A, this is point B, and let's say this length is 2 meters. Now you might have studied about this in your college or in your school. If I ask you, what is the moment of this force at B? What is the moment of this force at B? So the moment of this force at B will be force multiplied by this distance. Okay, this is known as the moment. We are going to study about this in future lectures. Right now I just want you to understand this simple example. Okay, so I am asking you to calculate moment of this force at point B. Moment is known as force multiplied by perpendicular distance. So we have calculated this moment as 200 Newton meter. Okay, now right now we have considered this distance to calculate the moment, but after applying this force, will this distance remain same? No. This body is going to deform like this, right? This beam is going to bend like this, and this distance is going to change. The angle of this force is also going to change. So this moment will not be exactly 200 Newton meter, right? It is not going to be exactly 200 Newton meter. After the application of the force, due to deformation of this body, this distance will slightly change. It might be 199.999 mm or 200.0001 mm. So it is going to slightly change. Now if I consider that deformation, then my calculation is going to become very complicated, right? If I assume the deformation of this beam in order to calculate the moment at B, then my calculation will become very complicated. Are you getting my point? Please let me know in the live chat. This is a live class, okay? So I want all of you to participate in this. So are you getting my point? Why do we assume that this body is rigid? Because we want to make our calculations simple. So in order to make them simple, we will just assume that, okay, this body is rigid, so this distance will remain 2 meters. So now I am getting moment at B actually 200 Newton meter. Even if you consider the deformation of the body, this answer is not going to change drastically. Even if, let's say, later in future you calculate the deformation, you get the exact distance, angles, all, then this moment will slightly change. So by assuming the body to be rigid, we are not going to make lot of errors. It will be a very low error, okay? It will be like 0.0001% error. So that is not going to change my design. So that is why, in order to simplify the calculations and in order to solve these problems, we assume that the body is rigid. So for these types of calculations, we assume solid body to be rigid body. So in this particular branch of mechanics, we are going to assume solid bodies are rigid bodies. We are going to make all those calculations. After making all those calculations, in the next step of design, we will consider the body to be deformable, okay, because there are some calculations where we need to consider the body to be deformable, okay. That you will study in the next subject, or you might have studied in another subject, okay. Now, in engineering, we study this subject as fluid mechanics, FM. We study this subject as engineering mechanics, and we study this subject as strength of materials, okay. So these are the three branches of mechanics which is in the syllabus of mechanical engineering: engineering mechanics, strength of materials, fluid mechanics, okay. So in engineering mechanics, we are going to study about mechanics of rigid bodies. So basically we are going to study about mechanics of solids, but we will assume that these solid bodies are rigids. We will not consider any deformation. Why? In order to make our calculations simple. So what exactly are we going to study? In engineering mechanics, what exactly are we going to study? Okay. So engineering mechanics can be divided into two parts: statics and dynamics. I told you in the beginning when I was giving you the definition of mechanics that mechanics is study of forces and its effects on bodies which can be in rest or in motion. Okay, you can either study the effect of forces on bodies which are at rest or on bodies which are in motion. For example, when we are studying about the bridges, when we are studying about the structures, then these are bodies at rest, right? Let me give you a small example. If I ask you to design the beam of your room, the beam of your room is a static body. It is connected to the walls, it is connected to the roof, it is connected to the columns. So it is subjected to forces from all sides. In order to calculate forces on this beam, you are going to apply the concepts of engineering mechanics which you will study here. So statics means we are going to study about bodies which are at rest. Okay. Now in dynamics, we are going to study about bodies which are in motion. Let me give you an example. We are going to study about if I kick a football, how high that football is going to go. If I kick a football at, let's say, 45 degree, how high that football will go, how far that football will go. These type of calculations. A car is moving on a flat road. I have given it an acceleration of 10 meter per second square. After 5 seconds, what will be the velocity of that car? After 10 seconds, what will be the distance covered by that car? So all this study comes under dynamics. Now dynamics is divided into two parts: kinematics and kinetics. Now let's understand about this. Dynamics means we are going to study about bodies which are in motion. So what comes under kinematics and what comes under kinetics? In some problems of dynamics, we are only going to focus on the motion of the body. We are not going to consider the forces acting on the body. See, if the body is in motion, it is subjected to some forces, right? But in some problems, we don't need to consider those forces. Let me give you an example, okay? Let's say I am dropping a ball from some height. Okay, let's say I am dropping a ball from some height. I want to know with what velocity this ball is going to hit the surface. Do you understand my question? I am dropping a ball from, let's say, this height, 6 feet. So if I drop it from 6 feet, with what velocity the ball is going to hit the surface? Or after one bounce, how high the ball will rise? After 5 bounces, how high the ball will rise? After how many seconds the ball will come to rest? All these questions come under kinematics. Here, in order to solve these problems, you don't need to consider the force acting on the balls. You need to only study about the motion of the ball. So kinematics is a part of dynamics where we don't need to consider the forces. We need to only consider the motion of the body. So we need to study bodies in motion without considering forces. And here in kinetics, we study the bodies in motion by considering forces. So we can divide the dynamics into two parts. There are some problems where we don't need to consider the forces. Let me give you another example. If I kick a football at 30 degree, how high the football is going to go or how far the football is going to go. In this particular problem, you don't need to consider the force acting on the football. I don't need to give you the force which I applied on the football. No. You will just consider the motion of the football. I will give you initial velocity and you will tell me what will be the maximum height, what will be the range of this. So all this information can be calculated without considering the forces. So that problem will come under kinematics. But if there are some problems where you need to consider the forces, then that problem will come under kinetics. In simple words, you can say that kinetics is the sum of statics and kinematics. In statics, we will study about only forces because here the bodies will be at rest. Here there will be no motion. So we are going to study about bodies at rest. We are going to study about forces. In kinematics, we are going to study about motion. But in kinetics, we are going to study about forces as well as motion. So it is the combination of statics as well as kinematics. I hope this is clear to each one of you. Chalo. Now, what are the chapters we are going to cover? Because a lot of you might be wondering whether we are going to cover this topic or that topic or this topic or that topic. So I am going to tell you what are the chapters we are going to cover in this complete course. Okay, so it is going to be a complete course of engineering mechanics. Okay, I will tell you for which exams you can refer this course. Okay, but first let me tell you about the syllabus. So we are going to cover 11 chapters of engineering mechanics. The first chapter will be about the basic concepts. Now in this chapter, I am going to cover about the basic concepts of physics. For examples, forces, moments, force vector, addition of vectors. Then I am going to talk about Newton's law, principle of transmissibility, Varignon's theorem. All these are the basic concepts which are related to physics, okay, and which concepts are going to be used in engineering mechanics. Okay, so this first chapter will deal with only basic concepts. Okay, forces, moments, couples, principle of transmissibility, all that. In second chapter, we are going to study about equilibrium. What do we mean by equilibrium? Equilibrium means net force is zero, net moment is zero. Okay, so here we are going to solve all the problems related to equilibrium. In the third chapter, we are going to study about friction and its applications. When I say applications of friction, there will be belt friction, there will be wedge friction, there will be rolling friction, there will be lot of types of friction, different types of problems related to friction. Okay, so friction and its application will be the third chapter. Fourth chapter is about truss and frames. What are truss and frames? They are basically structures. Okay, so in this chapter we are going to talk about how to calculate forces in members of truss and members of frames. In fifth chapter we are going to talk about centroid, center of gravity, center of mass, how to calculate the center of gravity, how to find out the centroid, how to find out the center of mass, what are them, what is the relation between them, all that. Okay, In the next chapter, we are going to talk about moment of inertia. I am going to explain area moment of inertia, mass moment of inertia, how to calculate moment of inertia, what is the significance of moment of inertia, everything. Okay. In the next chapter, we are going to talk about kinematics of particles, then kinematics of rigid bodies. So you might have understood that till now we are studying statics. Till this chapter we are studying statics, then kinematics, then kinetics, and the last chapter is a special chapter which was added in the syllabus of GATE recently, Lagrange's equation of motion. So this is the complete syllabus of engineering mechanics which we are going to cover in this course. I hope everyone is clear about this. If you are finding topics that might come to you, if you can't see those topics here, beta, probably we are going to cover that topic inside some chapter. Okay. For example, some people might be looking for translation, rectilinear translation. It all comes under this. Work energy principle, it all comes under this. Impulse momentum, it all comes under this. Okay. So here I have written only the names of the chapters. Okay. The topics, they will be under these chapters. Okay. So I am going to cover the entire syllabus of engineering mechanics. Now, who can follow this course? If you are wondering whether this course will help you for this exam or that exam, then let me explain who can follow this course. So this course will help all the students of GATE ME as well as XC. Now there are some other branches where there is engineering mechanics in the syllabus of GATE. Okay, there are some other branches also. For example, there is naval architecture, there is PI, there is chemical, okay, and there are different branches. I don't know exactly about them, so I will only write GATE ME and GATE XC. So this is one exam for which you can follow this course. Okay, but there are other exams also. For example, in engineering services also there are some chapters of engineering mechanics which you can follow. Then SSC AE JE exams, there are some SSC AE JE exams for which engineering mechanics is important. So for those courses also, for those exams also you can follow this. Semester exams, very important. In first year of some universities there is engineering mechanics. For example, in my university, when I was studying engineering, in my first year I had engineering mechanics as a subject. Okay, and that engineering mechanics, not exactly, but a lot of those chapters were from this syllabus. Okay, so if you also have engineering mechanics in your syllabus for semester exam, you can follow this course. Maybe not all chapters will be relevant for you, but whatever chapters are relevant, for example, basic concepts will be relevant, equilibrium will be relevant, maybe this Lagrange's equation of motion might not be relevant for you, but most of the chapters will be relevant for you. Okay, so if engineering mechanics is in your syllabus of semester exam, you can follow this. Okay, apart from this, in any other exam, if there is engineering mechanics mentioned in the syllabus, you can follow this. Okay, if you have any other exam in mind, if you are wondering about some other exam, you can write in the comments and I will let you know whether you can follow this or not. Okay, but I think most of you might be preparing for GATE, mechanical and XC, right? So for these exams you have to follow this. Okay, chalo. Next, what books do I need to refer, or whether I need to refer the books or not? First of all, we are going to cover entire theory and we are going to solve all problems in the class itself. So in my opinion, you don't need to refer any standard textbook. But let's say you want to refer a book let's say you have time and you want to refer a book, then I will give you suggestion of some really good books. Okay, so the first book that comes to my mind is R.C. Hibbeler. A very good book of engineering mechanics. Okay, statics plus dynamics. So you might find two parts of this book. There is one part for statics, there is one part for dynamics. Both parts are really good. There are lot of examples in this book and very good theory. Okay, so if you want to refer, then R.C. Hibbeler will be the first choice for me. Second will be Beer and Johnston. This is also another book, very good book that you can refer for engineering mechanics. Okay, third book which is very relevant for GATE, A.K. Tyal. Now this is an Indian author, A.K. Tyal. You can refer this book because it is very concise. In both these books there are lots and lots of examples. Okay, hundreds of examples are given for each chapter. But if you are looking for a book where you will find questions relevant to GATE only and which is concise, then A.K. Tyal is your book. It is an Indian author's book. Only these many pages are there. Okay, and all the chapters which are there in the syllabus of GATE, ME and XE are there in A.K. Tyal, and very selective questions are there. For each chapter you will find only 20, 30, 40 problems, but they are very good problems and they are very relevant to GATE. Okay, so these are the books that I would recommend if you want to follow books. But in my opinion, if you are preparing for GATE or any other exam, if you complete this course, if you follow this course, if you solve all the questions that I am giving and if you solve all the previous year questions, that will be enough. That must be enough. Okay, so you don't need to refer any book, but if you have time, then go for it. Okay, now comes the most important question which most of you might be wondering about. What is the weightage of engineering mechanics in GATE? Now I would talk about two branches for GATE. One is GATE Mechanical and one is GATE XE. If you are a mechanical engineering student, you must know about this, that you can fill the form of GATE from two different branches. You can write your GATE exam from two different branches. You can write GATE ME as well as GATE XE. What is GATE XE? XE stands for Engineering Sciences. Now in this particular exams, there are different modules, and out of those modules you have to, there are different subjects. Out of those subjects you have to choose any two. Okay, and there is one subject called solid mechanics. In that solid mechanics, there is engineering mechanics as well as strength of materials. Okay, now GATE Mechanical, in GATE Mechanical, if I see the trend of last 2-3 years, then I would say 6 to 8 marks question you can expect on average. 6 to 8 marks. Okay, in GATE 2022, in one set, I don't know exactly whether it was set 1 or set 2, but in one set there were questions of 9 marks from engineering mechanics. Last year, it means in GATE 2023, there were questions of 6 marks from engineering mechanics. 3 questions were there of 2 marks. So total 6 marks questions were there. So 6 to 8 marks on average, which is a very high weightage. Okay, 6 to 8 marks means a very high weightage. Now when I come to GATE XE, in GATE XE there are a lot of subjects which you can choose from. Okay, now if you choose solid mechanics, in solid mechanics there are 2 parts, engineering mechanics and strength of material, and solid mechanics is worth 35 marks. So out of those 35 marks, at least 15 marks is for engineering mechanics, at least 15 marks. So if you are preparing for GATE XC, then engineering mechanics means a very high weightage subject. And if you are preparing for GATE ME also, then 6 to 8 marks is a very high weightage. So this subject is very important. It is also a basic subject. So if you understand this well, it is going to help you in other subjects also. For example, if you understand engineering mechanics, then it is going to help you in strength of materials. It is also going to help you in theory of machines. It is also going to help you in vibrations. Okay, in strength of material, it will not help you a lot, but in theory of machines and vibration, if your concepts of engineering mechanics are very good, if you have studied each and everything, then beta, in theory of machines and vibration, it is going to help you a lot. Let me tell you, vibrations is nothing but a chapter of engineering mechanics. In some books of engineering mechanics, you will find vibration as a chapter. So if you study engineering mechanics well, then your vibrations is sorted. In theory of machines also, it is going to help you. A lot of concepts of theory of machines will be dealt in engineering mechanics. Velocity analysis, acceleration analysis, the basics of those concepts we are going to cover in engineering mechanics. So if you study this, then your theory of machines and vibrations will be sorted. You will not have to worry about these subjects. Okay. So I hope you understand the importance of engineering mechanics from the weightage point of view as well as a subject point of view. Okay. So this was the introduction of engineering mechanics which I wanted you to know about. Now from tomorrow onwards, we are going to start our journey of engineering mechanics. We will have the classes from Monday to Friday. Okay. 7 p.m. to 8:30 p.m. Okay, so we will have 1.5 hour class every day. Okay, we are going to cover everything. We are going to cover theory as well as lots and lots of numericals. Okay. Apart from this, if you have any other question from your side, then you can ask me that and I will try to answer, because this particular lecture, the first lecture, was just to understand what we are going to study, how we are going to study, and get to know each other. So do you have any question for me? Do you guys have any question for me? How long will it take to cover this subject? Beta, I am expecting at least 30-35 lectures. Okay, I want to cover each and everything, so I am expecting at least 30-35 lectures. So to complete 30-35 lectures, probably we will need 6 to 8 weeks of time. Okay, every week we will have 5 lectures, right? So 6 to 8 weeks and this subject will be completed. Okay. So I hope all of you have understood about this subject and what we are going to learn in it. Practice question. We are going to have all the practice question in the class, beta. I will give you homework questions also. Okay. So we are going to have all the necessary questions in the class only. Just follow this class and you will get everything. Anything else? We are going to solve previous year questions also. Whenever I will feel that you need to solve this previous year question related to this particular topic, I will incorporate that. Okay. I told you just now, practice questions will also, you will also get the practice question in the class itself. If you want to download the class PDF, then you have to go to the PW app. Okay. In PW app, if you go to the GATE section, there you will find free batch for GATE 2024. In that free batch, we are uploading all the lecture PDFs. Okay. So in the lecture PDF itself, I will give you the practice questions. Okay. Understood? Download the PW app or go to PW website, go to GATE section. There you will find free batches for GATE 2024. In that batch, I will upload all the lecture notes. There you will get all the questions. Okay. Anything else? Done? Chalo. So from tomorrow onwards, we are going to start our journey. Don't forget, the class will start sharp at 7 p.m. So I want all of you to be live sharp at 7 p.m. The classes will be live only. Okay. So please be live at 7 p.m. If you want to ask questions or anything, be live at 7 p.m. Okay. Chalo. So thank you so much. Thank you so much. And I will see you guys tomorrow. Bye-bye. Take care.